Hello, my name is Christian Pavlak, and this will be my first video for Mat650 Stats and Probability. So here we have a stats problem that I've presented in the past, and let's read through it, and then we'll tackle each problem separately. So Buckley Farms produces homemade potato chips that sells in bags labeled 16 ounces. The total weight of each bag follows an approximately normal distribution. Now that's very helpful to know because the normal distribution has so many nice properties as far as the computations go. With a mean of 16.15 ounces, so that is our mean, and a standard deviation of 0.12 ounces. So part A says, if you randomly select one bag of these chips, what is the probability that a total weight is less than 16 ounces? Okay, fairly simple. That's just a simple computation of a z-score to compute the probability. Part B, if you randomly select 10 bags of these chips, then what is the probability that exactly 2 of the bags will have a total weight less than 16 ounces? So I'm thinking some combinations in that problem. Part C, Buckley Farms ships its chips in boxes that contain 6 bags. The empty boxes have a mean weight of 10 ounces and a standard deviation of 0.05 ounces. Calculate the mean and standard deviation of the total weight of the box containing 6 bags of chips. Now that combines means, and there's going to have to be some extra computation to compute the standard deviation. And last, Buckley Farms decides to increase the mean weight of each bag of chips so that only 5% of its bags have weights that are less than 16 ounces, assuming that the standard deviation remains 0.12 ounces. What mean weight should Buckley Farm use? Alright, so let's go back up to part A and take care of this one. So it says, if you randomly select one bag of these chips, what is the probability that the total weight is less than 16 ounces? So this one this key right here, we want less than 16 ounces. So let me give myself some space right here. Okay. So if you randomly select one bag of these chips, what is the probability that the total weight is less than 16 ounces? So we're looking for the probability of x, allowing x to be the total weight of, so x will equal the total weight of a bag of chips. It's important to label. So we want x to be less than 16. Well, because this is a normal distribution, the way we're going to compute that probability is using a z-score. So this will equal the probability that z is less than, and what we're going to do is we're going to use x minus mu, which mu is the mean, of course, over my standard deviation. Well, our mean was given up here. Mean we denote with mu, and our standard deviation is right up here. So if I plug everything in, the probability that the z-score is less than 16 minus 16.15 over 0.12. So if I punch that together, I get a z-score less than negative 1.25. So in order to compute this probability that z is less than negative 1.25, I can use a z-table if I'm provided one, or the calculator can also do this for me. I would go to second, distribution, normal CDF, and then my lower I essentially put down to negative infinity, and my upper at negative 1.25. The reason being is, if I look at a normal distribution curve, if I set mu to be 0, and negative 1, negative 2, 1, and 2 are my standard deviations, I'm essentially looking for the area, everything below, right here. So I want to go from negative infinity to negative 1.25. I can use an integral, but it's much easier if the calculator is available. If I type this in, I will get this, 0.1057, which is telling me there is about a 11% chance, 10.5, 11% chance of randomly selecting a bag that weighs less than 16 ounces. Okay, excellent. Let's move on to the next one. For part B, let's give ourselves some space. If you randomly select 10 bags of these chips, then what is the probability that exactly 2 of these bags will have a total weight less than 16 ounces? So this is actually a binomial distribution because we're looking for the possibility that it does or does not. Well, what we want to let there be a y. Y is the number of bags that weigh less than the 16 ounces that we want. Well, in order to calculate the binomial distribution, what we need to understand is, well, the number of trials is 10. And the probability of a success, we're going to use that value we found from part A, which is 0.1057 approximately. Now we'll let the calculator deal with the entire value. But then I also need the probability of failure, which is 1 minus p, which would be 0.8943. So in order to calculate the probability that we'll have exactly 2, what we need to do is we need to calculate the 0.1057 to the power of 2, so there's 2 opportunities of success, but then we have to ensure ourselves 8 opportunities of failure. Now the one thing that I'm missing currently is the fact that in this probability, I do not assume, I am assuming that I have an order. I can have any 2 bags weighing less than 16 ounces. So what I need to do is I need to set up a combination of 10 choose 2 to complete a binomial distribution. This is going to go into the calculator, and let's see what we get. So let's take the time to store this value as P, and now we will do 10 math probability and CR, because it's a combination, 2, okay, that's going to come out to 45, and then we're going to multiply that by P to the power of 2 times 1 minus P to the power of 8. And we get 0.20559, so approximately 20.5% again. Let's go back to here. This will give me approximately 20.20559. So we can say there is approximately a 20.5% chance or probability that exactly 2 of the 10 bags selected at random weigh less than 16 ounces. Okay, moving on. So, part C says, Buckley Farms ships its chips in boxes that contain 6 bags. The empty boxes have a mean weight of 10 ounces and a standard deviation of 0.05 ounces. Calculate the mean and standard deviation of the total weight of a box containing 6 bags of chips. So it's really important because we're trying to calculate the mean of the box. It's like a combined value, a combination of one box and 3 bags of chips. So we can think about that. The mean should be easy to compute. The mean of the combined values, so I'm going to call that mean and then sub C for combined, should equal the mean weight of the box, which is 10 ounces, plus 6 times the mean weight of each of the bags of chips, which was given in the very beginning. This comes out to be 106.9 ounces if we can use a calculator. Now, that was the easy part. The standard deviation is a little bit trickier. What we have to understand is the standard deviation is not just the sum of the standard deviations, because that doesn't tell us how much it will deviate from. The first thing we have to do is we have to find the variance. So we want the variance. It's really just theta squared or sigma squared, and I'll again denote that by the combination. In order to compute this variance, what I'm going to have to do is I'm going to have to take the standard deviation, or really the variance of this one, standard deviation squared, 0.05 squared, and then add it to 6 times the standard deviation of each of the boxes, which was 0.12 squared. This comes out to be roughly 0.1364. So in order to calculate the standard deviation, that's really easy. It's just the square root of the variance. So the square root of 0.1364 equals approximately 0.369 ounces. And we're going to round to 3 decimal places because that's the AP standard practice. So here's my answer for the standard deviation, and here's my answer for the mean. Okay, last problem. D. Buckley Farms decides to increase the mean weight of each bag of chips so that only 5% of bags have weights that are less than 16 ounces. Okay, that's actually really important. We're trying to increase the mean weight of each bag of chips, but we want to make sure only 5% of bags have weights that are less than 16 ounces. Okay, so that's actually telling me the probability. Assuming that the standard deviation remains at 0.12 ounces, what mean weight should Buckley Farms use? So to kind of organize our thoughts, let's readdress some variables. Let x still be the same x from what we had before. And I'll abbreviate this: total weight of a bag. Okay. Since we are assuming that this is a normal distribution still, the one thing that we do know is the mean, or the standard deviation rather. The standard deviation is still 0.12 ounces. What we don't know is our mean, and we'll call that capital M. We want to find the value of M so that the probability that x is actually less than 16 equals 0.05, because that's what this is saying. Only 5% of the bags have a weight less than 16 ounces. So we're translating that into a expression. So we're trying to figure out, okay, an area, back to our normal distribution. This is our normal distribution. Since we don't know the mean, but we do know the standard deviation, we're trying to find an area such that the area of this equals 0.05. The mean will stay in the middle. That'll be our mu. But again, we do not know what this mean is. The only thing that's given is the standard deviation. So what we need to compute is we need to figure out what z value corresponds to 0.05. In a normal distribution, we would have put 0 in the middle and 1 as our standard deviation. So let's convert that using our calculators again. So here's my calculator. What I can do is, again, if I had a z table, I would just refer to that. But the calculator can do the same thing for us. We go to distribution, and we go to inverse normal. And we can compute. We want the area to be 0.05, and we're just going to leave that be. And this allows us to have that z-score. So we know that z will equal negative 1.64, it was approximately 5. Okay. Well, the formula for the z-score, if you remember, is x minus mu over standard deviation. So in this case, negative 1.645 equals 16 minus, I do not know the mean, but that's what we're looking for, over 0.12. And with a little algebra, we come up that the mean is 16.1974. So this means that if we want to have 5% of the bags weigh less than 16 ounces, we really are trying to aim for a mean of 16.197 ounces. So to conclude, let's write a sentence. The mean weight should be 16.197 ounces in order to make sure that less than 5% of bags are under the 16-ounce threshold. That concludes this video. Thank you very much.